I'm going to take a quick look at fission and fusion here. Fission is how we make electricity on a large scale across the world. Most large-scale power stations, not all of them, but most of them, are basically very large kettles. They use some means or other to boil water, to make steam, to drive turbines, to make electricity. And nuclear fission, which is about the splitting of the nucleus, and it's important you talk about the splitting of the nucleus rather than the splitting of the atom. It is the splitting of the nucleus we talk about. When the nucleus is split, it releases energy. So uranium-235 is a typical fuel for nuclear power stations, and well, that's a little bit dramatic. The idea is that when the uranium-235 nucleus absorbs a neutron, it becomes unstable, it splits, fissions, and releases energy. Two daughter nuclei, typically barium and krypton, as we'll see in a moment, and two more neutrons. Now, those neutrons could go on to be absorbed by other uranium nuclei, and so one fission could lead to two fissions, could lead to four fissions, and so the reaction can accelerate, a chain reaction, and that makes a bomb. So we need to control that in our nuclear power stations. I should say that uranium is a natural neutron emitter. We have up to now talked about alpha, beta, and gamma decay. We also have neutron emission. We don't talk about it except in this context of nuclear fission, but neutron emission is another form of nuclear decay, and uranium nuclei naturally decay by neutron emission. So when your uranium nucleus splits, typically you get barium and krypton, not always, and you get two more neutrons in addition to the one that came in the first place. And every time that fission occurs, you get energy released. Now here we have a comparison of the amount of nuclear fuel needed compared to the amount of coal needed, and you can see 1 kilogram of uranium produces the same amount of energy as 3 million kilograms of coal. So you can see the attraction of nuclear fission as a power source. You know, without my telling you, many of the issues surrounding nuclear power, the risk of accidents, the risk of contamination from nuclear waste, and the fact that nuclear waste, some of it, is really a permanent problem. But the attraction is that you can get a lot of energy from a small amount of fuel. A large energy density is how we might put that. Nuclear fusion, however, fission is the splitting of atoms, nuclei, whereas fusion is the combination of light nuclei to make heavier nuclei. And in that combination, energy is released. Now, the problem with nuclear fusion for us is making it happen in a sustainable and economic way. One of the problems we have is that while stars do this, they produce their energy by nuclear fusion, they do it under much greater pressures than we can produce on Earth. And so in order to compensate for that, we have to increase the temperature. So whilst the sun might do what it does at 1.5 million degrees C, we need to do it on Earth at 100 million degrees C. And clearly the energy required to raise the temperature, the energy required to contain your fuel at that temperature is substantial and is about the same as the energy released from the reactions, which isn't good enough. We need it to be about 7 times greater released so that it's economic. It says 50 million here, it's more like 100. So you take deuterium and tritium, two isotopes of hydrogen, and you make them collide so fast at such a high temperature that they fuse and form helium, and there is energy released. The big benefit of this, well, we have no limit really to the amount of deuterium and tritium that we have on Earth. We get one of those two from seawater. The nuclear waste that is produced, there's a small amount of it in comparison to nuclear fission, and it is short-lived. So it isn't the long-term problem that nuclear fission produces. And with nuclear fission, if it all goes horribly wrong, the reactor can blow up. We have an example of that with Chernobyl, for example, some years ago. With nuclear fusion, if it all goes horribly wrong, it stops.